not make as much sense. So please go back and watch it if you haven't watched it, but if you have, just continue watching. Thank you. This is the rocket I'm going to build. The body of the rocket is made from a cardboard tube, the parachute will be cut from a trash bag, and everything else will be 3D printed. These were all modeled in my CAD modeling software SolidWorks. The 4 parts all attach to the tube. The wings and the rocket engine mount are the large piece that attaches to the bottom of the tube, next to the parachute plug that slides down the top of the tube. The parachute will slide down on top of that, and finally the nose cone is then put to top everything off. In my last rocket video, there was a problem with parachute deployment. There was no buffer zone in between the reverse thrust of the engine and the parachute and the rest of the body. Because of this, the rocket structure of my last rocket melted. What I've done to now mitigate this is change the type of material the body of the rocket is made of. My last rocket, it was very thin 3D printed plastic, which has a very low heat tolerance to something like that. So the flames just came up through here and melted the body of the rocket. And so now I've changed it to cardboard. And it's quite thick. It's a little over 1 millimeter thick cardboard, which means it has a higher heat tolerance to the flames coming out of the end of the rocket engine when it pushes the parachute out. So instead of immediately melting, the cardboard wants to burn, and the flames don't come out long enough to set the cardboard alight, causing my rocket to catch on fire. Now, another fix I have is the parachute plug. Now what the parachute plug does is it acts as a projectile inside the rocket to help push up the parachute. So if I put it in like this is the first thing that goes into the top of the rocket. And so whenever the engine reverse thrust through the tube, it hits that parachute plug and tries to launch it like a projectile. But because the parachute sits on top of that as well as the nose cone, instead of launching out, it pushes the parachute and the nose cone off, allowing the parachute to come out and deploy. And to show you how much easier this makes it, the human lungs can only blow out in about 10-ish psi. That's 4 psi less than what it feels what atmosphere pressure feels like when you walk outside. And so I got a little paper thing here to simulate my engine, but I'm going to blow into it. I'm going to show you the parachute plug, which is in there, coming out. You probably couldn't see that because it was so fast, but it launched clear out of the tube, and I've honestly lost track of it, so I can't find it anymore. But hopefully these mitigations really help with parachute deployment, because that was really my only problem last time. Here is a quick animation of the parachute plug pushing out the parachute and the nose cone all at once. Here are some pictures of the rocket fully together. As you can see, the nose cone and the parachute are held together by a single string. This is all put together to help pull the parachute out, because when the nose cone is pushed off, it now has a weight outside the rocket to help propel the parachute outwards. Now it is time to launch the rocket. Here I am just getting some close-up shots of how the engines are connected to the wires to help self-ignite. And all these do is run a current through the wire that heats up a tiny little wire that's inside the engine. Now, this tiny little wire heats up to basically be so hot it can catch the insides of the solid fuel motor on fire. And I'm going to pass it over to me to take it away for launch. Before I launch this, I really want to give a disclaimer to you guys. It's not a good idea at all to do this in any other weather besides clear weather. The only reason I'm doing this is because of a time crunch, and I'm aware and understand the risks involved in doing it in weather like this. With that being said, rocket is armed. And in 3, 2, 1. Come on, deploy. Yes, it did. By now you've already heard my excitement in the video, but that was because the engineering process worked, and our rocket deployed the parachute and came down gently exactly as planned. I was even able to catch it at the end. I think it's time to see that launch in some slow motion. Well, there it is. just like last time. I followed the engineering design process, and I was able to get a final, complete, working rocket from my problems that I issued before. Like I said last time, as long as you follow that process and keep iterating and iterating, continuing on and on, you will always get a better result than you did last time. Now, eventually this does come to a little bit of a halt, but every time you do it, you will get an increase every single time. It's a great thing to do because, in my opinion, I mean, this rocket looks way better than my last rocket. And it's all because my first rocket had to fail for me to be able to iterate on it and make it better. So, thank you guys for watching. And this will be my last video I'm putting out for a while. I've got to go back to school. So, I thank every single one of you for watching. It's been a great time. I've had so much fun making these videos. So, just thank you to everyone. Goodbye.